We are in geometry. We are in lesson 10-6. We're talking about inscribed angles today. So in general, I want to talk about the difference between a central angle and an inscribed angle. The central angle is ACB, aka the angle that is in the center, whereas an inscribed angle is an angle that goes to the edge of the circle. So ADB is our inscribed angle. An inscribed angle has a unique property, which is this. If I take a look at the difference between the central angle and the inscribed angle, the central angle is twice as big. I didn't know that was enabled, is twice as big as the actual angle, or vice versa. You can say that the inscribed angle is 1/2 the size of the central angle. And it can kind of visually see it, right? So if I have an angle that looks like this, half of this angle looks like that. You just multiply by 2 or divide by 2, depending on the scenario. So our official formula is the measure of the central angle is twice the measure of the inscribed angle. So the implication is this. If I have some sort of diameter, what is the angle of the diameter? What is the angle of the diameter? What is the angle of a line? That's 180 degrees, which means this angle down here is half of 180. Therefore, it's 90 degrees. So angle F is 90 degrees. So that will help you in a few of these other problems. Let's dive into an example. In example 1, I want you to find this arc measure. I need to find this arc measure. I know that this angle right here is 42 degrees. Think about this one. How do we do this one? So a great first step is to use the fact that we have an inscribed angle, meaning that if I have an inscribed angle right here, that means its corresponding central angle is double the amount. So if this angle is 42 degrees here, this central angle that also intersects C and Q that you can't see here, I have to draw this imaginary line here and here. This angle right here has double this angle, and I can say that this angle is 84 degrees. We all nod our heads. That's how inscribed angles works. That's the new thing that we learned, which means that this arc measure right here is the same as the central angle is also 84 degrees. Okay, I told you that we're going to use this property of having a diameter here. This diameter over here is what? How many degrees of the circle? 180, because it's a diameter, right? So I can say that this entire length here to here is 180 degrees. And our last step is to do what? Subtract. Yeah, Eli, do it for us. 96 degrees. There's our final answer, and box it. Let's try another one. Sometimes we have inscribed shapes in here. Whoa, don't know what happened to the iPad there. Sometimes we have inscribed shapes. Again, this is our inscribed angle that I'm looking at, which means that this entire angle we can figure out over here, this entire arc length we can figure out. What should this, and that's my first question for you guys, between N all the way through M to L, this arc length over here is what? We can figure it out right now just knowing properties of inscribed angles. Try it, Valentina. It is indeed 224 degrees. Tell us why that's the answer. Yeah, 112, we double it. It intersects here and here, which means it's an inscribed angle here to here. This angle is bigger than 180. It's 224. Therefore, this arc length is also 224 degrees. So if I happen to know that this entire arc length is 224, that seems to not really help us too much, because we're trying to find this inscribed angle right here. But we can start filling in some missing information. Because I know that this arc length is 164 and this entire arc length is 224, I can find this arc length between M and L. And subtract the two. Zane, go for it. I have 224. I need to subtract away the 164. 4 minus 4, 0. 22 minus 16. 6, so 60. So I know that this arc length is 60 degrees for L and M. The arc measure is 60 degrees, not arc length. Okay, we're almost there. Notice I have three pieces. I have 164, 60, 60, and this unknown angle, or this unknown arc measure. I can find that unknown arc measure right now, and that would be useful because I can say that this inscribed angle here will be half of this entire arc measure. So if I find the entire arc measure, I just take half of it. So how am I going to find this? I'll take any volunteers. Eli. Yep. So if I add all three of these together and then do what? I can say that 60 plus 60. Oh, that's a bad zero. 60 plus 60 plus 164 plus this missing angle is equal to 360. I'm going to call that missing angle, let's call it y for now. Plus y is equal to 360 degrees because that is the entire outer measure of the circle, which always adds up to 360. And you correctly combine the first two and saying, okay, those two combine to 120. 120 plus 164, 284 plus y is equal to 360. Someone else step in here. Felipe, you want to try to join us? 284, you want to subtract from both sides? $124, not quite. What I can do here is I can cheat a little bit. I can say add 16, so the bottom becomes minus 300, and the top becomes 374. Or 376, sorry. And then you see what I did here, Felipe? If I add 16 to 84, it turns into a nice 300, but I have to add 16 up here as well, and I can find a new, easier problem. Can you stop it, please? Y is equal to 76, which is almost done. We can say that this is 76 up here now, 76 degrees. How do I find this missing inscribed angle? I said it twice before we started solving for y. Half of what? Close. Look at the inscribed angle. The inscribed angle goes here to here, so it's really referencing this entire arc measure. So I need this entire arc measure and then take half of it to get to the inscribed angle. So I need to add these two together, Valentina. $136 degrees. And then what do I do to get from 136 degrees, which is this entire arc measure, back to this inscribed angle? Divide by 2. Tell us what that is. 68. 68 degrees is our final answer. All right, let's move on to example 3. Again, now I'm going to be using inscribed angles, but now instead of just finding missing angles, I'm solving for x. Take a look at it. What are we going to do here? What's any missing information that you can find? It doesn't necessarily have to lead us into the right direction, just anything that we see. If it leads to the right direction, hooray. If not, oh well, we're still reviewing properties. What do we see? You see anything, Felipe? What about this triangle? If we only focus on that triangle and ignore the circle, what's something that's unknown that we could figure out in this triangle? I see Eli has his hand up. I want more people to think about this. Eli, tell us. You can indeed, yeah. So, well, not 360 though, right? These three interior angles of a triangle always add up to 180, exactly. So let's go ahead and temporarily call this thing a variable. We'll call it y for now. I can't use x because x is already used down here. So I can say if I add up those three angles, if I add up 78 plus 56 plus the y, they should add up to 180, and I can solve for that. So 78 plus 56, what is that going to be? 134 plus y is equal to 180. And then I can subtract 134 from both sides, subtract 134 from both sides. Y is therefore going to be equal to 46. So I now know that this angle here is 46 degrees. Now what? We haven't used any properties of inscribed angles yet, so we're probably going to have to use that sometime. What do you guys see? Is there a relationship between the thing that we just found and this expression that has an x in it? I see Valentina nodding her head yes. I need someone to explicitly state what that is. Melly, you want to give it a shot?
Good.
Melly, how do you get from an inscribed angle to the central angle? So this central angle right here versus this inscribed angle. What's the way to get from here to here? Double it. Yeah. So I can go ahead and we'll do an intermediate step here and we'll say if I have an angle like this angle should be what, Melly?
92.
Should be 92 degrees. 92. And what do we know, Melly, about the central angle and this arc measure that corresponds to that central angle?
That equals to 180.
That they're equal to each other. This arc measure is this arc measure. They are the same measure. So I can say that this 92 is equal to this 11x minus 7. So I'm going to come over here and say I have 11x minus 7 equal to our 92. And then from here we can solve. Melly, go for it. Then what?
X equals to 9.
Yep. And then x is equal to 9. We were just asked to solve for x, and we solved for x. Done. All right, let's try one final example, and then we can be done with the notes. Again, I'm trying to solve for x here. What's something that we could try to figure out? Anything that's unknown that you could potentially know. Valentine, did you see something? Let me give everyone a hint. Look at the inscribed angle first. This inscribed angle right here, 76, is going to refer to this entire arc measure out here. Can we somehow figure out what this arc measure is right here? Felipe, what is it? You got to participate eventually in the class. How do you get from an inscribed angle to a central angle? How do we get from here to here? Divide by what? Close. Notice that this angle is kind of small and this angle is really big. Multiply, yeah. Multiply by 2. You're either dividing by 2 or multiplying by 2 with all inscribed angles. If it's getting bigger, multiply by 2. If it's getting smaller, divide by 2. So to get from here to here, it's bigger. We multiply by 2. Felipe, 76 times 2?
142.
Close. You have to carry the 10.
Oh, yeah. 152.
152, which means that this central angle is 152, which Felipe means that this arc measure is also 152. So I know that this whole thing adds up to 152. How do I figure out what this, let's go ahead and give it a temporary variable. Let's call it y. How do I figure out what y is? Someone other than Felipe. You want to try, Zane? Felipe just told us that this entire thing adds up to 152. I have these two things. Exactly. Yep. And then from here, we could subtract 72, subtract 72. Y is going to be equal to, well, these 2's are going to cancel out, right? What's 15 minus 7? Yeah, exactly. So we get 8, or AD, because the 2's and 2's made a 0. So we happen to know that this is 80 degrees here. And look at all the information. We're just filling in information. I know this measure. I know this measure. I know this measure. What would be really helpful if we're trying to solve for x and I have this inscribed angle? Which of these 4 pieces would be the most important to know? The top right and the top left, which we already know. So yeah, top right is kind of what we want to find. If I can find what this arc measure is right here, add it to the 72, that refers to our inscribed angle that we have down here for our 13x plus 3. So what I'm after right now is, what is this arc measure? How are we going to find that? Yeah, we all add them up and they set them equal to 360. So I'll call this W for now. So let's see if I have enough room down here. So if I do 80 plus 118 plus 72 plus the variable that we need and set it equal to 360, we can therefore solve for that remaining angle. All right, I'm going to do my 72 and 118 because a 2 and the 8 makes a perfect 10. I'm making this 120. 120 plus 7 is 190. So this is going to be 190 for these two. And then I can do 80 plus 190, which is going to be 270. Which means W is what? Someone help me for my final answer. Say it louder.
90.
It is indeed 90. So we can come up here and say that this angle up here is 90 degrees. And we're almost ready to, I think we're basically ready to set up our equation. I want to somehow have an equation with x. And I know that in order to get from here out here, I do some sort of operation about an inscribed angle. What do I do to 13x plus 3 to get it to this exact measure out here? Do I multiply by 2 or do I divide it by 2? So I'm trying to get from this inscribed angle to essentially this central angle, which is the same thing as saying this arc measure. What do I do to 13x plus 3? Do I multiply by 2 or divide by 2 to get to this arc measure? We're going to multiply by 2. So I'm going to say that as an equation. So I'm going to say this 13x plus 3. 13x plus 3. If I multiply that by 2, I get the entire arc measure, which is 90 and 72 added together. So I'll say 90, and then I ran out of room here. Move you over. 90 plus 72. And I have my final equation. I just need to solve for x. All right, I need everyone to just shout these out because we're almost done with the notes. What do we want to do first? Combining the like terms on the right. Okay, the right terms are going to be 162. What about the left? Distribute. 2 times 13x is 26x. 2 times the 3 is 6. Then what? Shout out. Minus 6 minus 6. So I get 26x is equal to 156. And then from there, divide both sides by 26. Divide both sides by 26. X here is equal to 6. And we get our final answer. A lot of work for example 4. That's kind of what is expected from you guys too. It's just playing with the problem, knowing all the different properties, knowing that you can add up to 360 degrees, knowing that there's this little trick over here that you can get 90 degrees from a diameter. It's just using this one rule over and over with all of our existing rules at the same time. Cool. A quick fist of 5. How well did we understand the lesson? I know that it was a lot, especially for a Friday. I'm seeing a 4, a 4, a 4, 4, a 5, and a 3.5. All right. Thank you guys.